the ESD event buster tip. Below is our presentation video. Electrostatic discharge events significantly threaten highly miniaturized integrated circuits. Our team has developed the ESD event buster, a real-time ESD monitoring system for IC production lines. Our presentation outline includes first, the circuit architecture, second, the layout and simulation result, third, die photograph of the strip and measurement results, and finally, the practical application of the system. Let's begin with the introduction and circuit schematic. Starting from the left, the circuit features a bias generation circuit, followed by a logarithmic amplifier and a comparator. The signal is then sent to the magnitude discriminator, which outputs the strength of the ESD events, and the duration discriminator, which outputs the duration of the event. With this, we can monitor the magnitude and duration of ESD events in real time, aiding in ESD event management on the production line. Now, let's move to the simulation results. As illustrated in red, we input 5 ESD events of varying magnitudes and durations. As shown in yellow, the logarithmic amplifier provides different output waveforms based on the event's magnitude. The green waveform indicates that the first 4 signals due to their short duration were detected as ESD events, while the last signal due to its longer duration was classified as common electromagnetic interference noise. We also show the outputs result from magnitude discriminator and the duration discriminator. Here is the circuit layout. The chip area is 693 × 693 micrometer squares. The capacitor matching array below forms the core of duration discriminator, while the comparator array on the right is the main structure of the magnitude discriminator. The logarithmic amplifier consists of a cascaded limiting amplifier in the center to control the amplitude. This completes the preparation and design process of the circuit. Now, let's move to the die photograph and measurement results. This circuit was fabricated using TSMC's 0.18 micrometer process with the assistance of Taiwan Semiconductor Research Institute. After 3 months of manufacturing at Taiwan Semiconductor Manufacturing Company, the chip was photographed under a microscope. On the left, you can see the layout diagram, while the right shows the chip as it appears under the microscope. The different circuit blocks are visible under the microscope, as shown in the image on the left. The area is 693 × 693 micrometer squares. Next, we see the chip after packaging. The packaged IC is then soldered onto a breadboard to facilitate final measurements. Additionally, it is integrated with an Arduino Nano 33IF module to form the ESD event detection and reporting system. Now, let's look at the measurement setup. We simulated the IEC standard test environment using an ESD gun to discharge the device under test. The battery-powered ESD event detector captures the ESD event characteristics and sends them to the control center via Wi-Fi module. Secondly, let's delve into the ESD event detector field detection. On the left is a signal source of an ESD event generated by an ESD gun zapping on a PCB board. On the right is our ESD event detector, which is powered by 2 batteries and requires only a simple SMA cable to function as an antenna. First, it does not require an external power supply because it is powered by just 2 batteries. Second, its antenna is very low cost, making it feasible to deploy multiple units in production areas where ESD events may occur for monitoring purposes. Here is our control center. When an event is detected, the results are transmitted via the IF module located on the next stage of the ESD event detector. The signal is sent to the Google Sheet or Google Cloud over Wi-Fi. We can then remotely monitor the data on our Google Sheets. To gain real-time insights into the status of ESD events, connect the ESD event detector to the battery power supply. There are no data on the Google Sheet initially. Next, we will trigger an ESD event, and we can observe a powerful discharge like lightning. On the Google Sheet, we can see the magnitude discriminator output as 2 and the time discriminator output as 3. After completing the first stepping and repeating the operations, we can obtain the following data. The first discharge occurred at 6:36 and 25 seconds p.m. on April 9th with a magnitude discriminator output of 2 and a time discriminator output of 3. The last ESD discharge took place at 6:37 and 13 seconds p.m. with a magnitude discriminator output of 5 and a time discriminator output of 3, indicating it was the strongest of the discharges. The time discriminator output of 3 signifies a duration between 200 nanoseconds and 450 nanoseconds, characteristic of ESD events from the ESD GAP. Ultimately, we can compile all ESD event characteristics and monitor them in real time on any internet-connected device. This represents the ASIC solution developed by our team ESD Event Buster for ESD monitoring in IC manufacturing processes. Since the output results from our ESD event detector are transmitted to the cloud via Wi-Fi, we enable real-time monitoring and data accessibility from any location with an internet connection. We can view the ESD signal detected by different detectors at various times directly on Google Sheets, and the outputs of magnitude and time discriminator. We can observe and monitor the results on many devices such as notebook, iPad, iPhone, and so on. Since the Wi-Fi connection ensures synchronization across different devices, we are able to achieve highly efficient ESD event monitoring. Let's go to the field application and setup. This page shows an application scenario of ESD Event Buster in the wire bonding and packaging test environment. When an ESD event occurs, the system detects it in real time and uploads the magnitude and duration to the factory control center. This allows immediate action to neutralize static charges on the machine and perform additional electrical testing on semi-finished or finished products made during the time period to eliminate defective items. ESD events frequently cause significant yield losses during semiconductor chip mass production. With the ESD Event Buster developed by our team, ESD events can be monitored 24 hours a day, 7 days a week, and alerts can be sent in real time to factory personnel responsible for IC manufacturing environments to promptly address and resolve ESD issues. Long-term monitoring and statistical analysis can also help identify areas or machines with a higher likelihood of ESD events. Targeted measures can then be taken, such as increasing the frequency of ESD mitigation efforts or installing additional static detection systems in these areas, ensuring a smoother production and manufacturing processes for ICs. Thus, our team ESD Event Buster provides the optimal solution for ESD event control. Thank you for your attention.